The reviewing team cannot see the presentation. Maybe if you could wait a couple of seconds. And Ilya, you're on mute if you want to tell us something.
Sure. Yeah, so we were just waiting for the confirmation from team, from the opposing team that they are ready. Let me just pause the clock for a short second and then we'll be ready to start.
Does everyone see the presentation?
See the presentation?
So can everybody see the presentation?
I cannot see it now.
We can't see it either.
No. Okay, so we ask the opponent to please disconnect. Please switch off your stream and then start.
Look in the noise. Galaxies of Hubble.
Can you see it now?
Reporters.
Yes, I can see it clearly.
I can see it. Okay. Apparently we can start. So let me start the clock and let's welcome the opponent.
Okay. So hello everyone, I'm Young-So Kim from Team New Zealand and I will be opposing problem 16, weak signals. So here's the problem statement. Controlling the signal to noise ratio is important in many measurements to distinguish a meaningful signal from a statistical fluke. Now propose a problem requiring experiments to detect very weak signals. Here's a reinvented problem statement. To make an investigation based on data with a low signal to noise ratio to explore a distant space object. So first of all, I'm going to be addressing the problem. So regarding defining key terms and defining signal to noise ratio, I wasn't completely sure. They didn't define many of the key terms such as signal to noise ratio or statistical fluke. However, the ones that they did define did relate to their problems. Just the link to this and the key, question statement was slightly weak. Theoretical understanding and explanation of their theory, I thought this was very strong. They seemed to definitely have a very good understanding of everything that they were doing, from the mathematical equations to the theory behind everything, and it was a very good explanation. All I would have asked for is just something more, again, relating to the original question statement. For their practical, their experimental setup was strong. However, the trials they did, the controls they used, and the accuracy, this was very badly defined. I didn't hear a lot about this. And not to mention the practical link to the theory, which they did later clarify in the clarifying questions, but overall in their presentation, I wasn't entirely sure of this. I was only sure to an extent, so that's why I wasn't very certain about their practical. Their data, they used graphs, they accounted for all of their errors using standard deviation, and they did also use a mean. So I just thought that all of their data that they used was most likely very valid. So yes, to summarize, they could have defined more. Their theoretical understanding was very good. Their practical lacked in trials, controls, and accuracy, although trials, yeah, it lacked in controls and possibly accuracy. Their data, however, accounted all of the errors and was valid. So going on to their strength, I thought they had very good theory regarding what they were investigating, and the data they acquired seemed very legitimate. This is, again, their graphs and everything, this seemed very accurate. They had a very good experimental setup with a very seemingly high-quality equipment, and the results were very accurate using a mean and standard deviation. Some weaknesses in their theory was that the theory to practical link was slightly weak, and they possibly could have had more theory relating to terms from the question statement. So since the original problem states something about a statistical fluke, they didn't really have this well defined, and the reporter just generally didn't define many key terms from the statement. So I wasn't sure if their investigation would have been completely complete in terms of the original question. Their practical was quite good, but just some weaknesses was, again, accuracy, and just, again, was accuracy and based on the collected data and then the controls that they might have done. I wasn't too sure about that. So yeah, I'd like to go over that in the discussion. And they also generally just what was being asked by the question statement was slightly lacking. So some points for discussion. First of all, we like to ask about the accuracy of the telescope. Again, controls were undefined. We were wondering if the inaccuracy of the bulbs would affect the data produced, and how they attempted to minimize unwanted noise, or the light in their case, because this wasn't very well defined. So I would like to welcome them up for discussion. Thank you.
Okay, let's first thank the opponent for making your statement and making your points clear. Thank you very much. And now we move on to the discussion between the reporter and the opponent.
Okay. I am ready for the discussion.
Okay, so could you just let us know how accurate the telescope was? Like, how did you define like that the telescope was very accurate?
Well, the telescope was with a 14-inch aperture, and the observations were made with during calm a night with calm atmosphere, with a full width at the half maximum of the Gaussian smear for every of the stars, being 2 arc seconds. Second of all, we used three images in every filter, and
you
perhaps
that.
the more important part would be the accuracy of the CCD matrix for obtaining the data.
Great.
This
Could you tell us about that then, please?
yes, this CCD matrix was with a subtracted dark frame and was divided over a flat field. That means that first observations
Okay.
were made of a
Just
object with
yeah.
uniform brightness. That
So
had
from your
so
answer, I can
so
definitely
the
tell that the telescope, like regarding aperture and everything, was very accurate. Thank you for that. However, what I'd like to move on to sort of regarding that as well is how did you attempt to minimize the unwanted noise or the light in this case, or did you even attempt that?
the light, the unwanted noise in this case, the observations were made in at a steady atmosphere in a place that is far from light pollution. As well, we used the background light from the galaxy. We used the background light as our noise, and the deviation in this background light actually
You
served as
didn't
a
do,
statistical fluke. And
but you
when
didn't do
subtracting
anything.
the
Could you, excuse me, I'm really sorry to
yes,
interrupt you. Just to clarify though, you didn't do anything, you just chose an environment that had less light pollution, but you didn't do anything to actually minimize the unwanted noise?
this
Just
is
to
the
clarify.
this is what we use to minimize the unwanted noise, exactly, from light sources that
Okay.
would be near, and also we subtracted the background of the image from every of the from each of the probes, so that we know that in the data analysis the only light obtained is coming from the galaxy itself.
Okay. The next question I had was, how did you define statistical fluke? Because I didn't hear a lot about that in your presentation.
Statistical fluke in our case serves as it is defined as the standard deviation of the mean intensity of the background, which is obtained using the IRIS software program. And also, this statistical fluke is to define the noise, signal to noise ratio, determining.
So I understand that, but I just don't understand how that links exactly like to the question statement and also to your
Well, for example,
presentation.
we also use the method of isophobes, since one isophobe takes the average of the so takes points with equal brightness and connects them. We used elliptical fitted isophobes to eliminate effects from bright stars that would be on the way of the observation to the galaxy, and would put inaccuracy into the data. The isophobe fitting is actually the method that we used in order to eliminate this inaccuracy.
So you're saying that you eliminated the inaccuracy using both standard deviation and what you just said.
We used the isophobe fitting as well, yes, but
That's just like yes and no, please.
the data we obtained is nonetheless accurate, since
Okay.
we have a lot of measurements near the edge of the galaxy. A lot of
Okay.
isophobes are there.
That's very good, thank you. What I just wanted to quickly cover, since we don't have much time, is since you said that the bulge doesn't have a strict definition, don't you think that sort of has an effect on your data that you
It doesn't have a strict boundary, but it does have a definition. It's the place with older stars and less intensive star formation, as well as many globular clusters. However,
And you're telling us that
you
you
would
calculated that
you,
using
you we use that we use de Vaucouleurs interpolation in order to
yes?
measure the bulge. And as you can see on the graphs of the model we fitted, the bulge itself in B is not very prominent since stars there are generally older and more red.
Great. That's all the time we have, so thank you very much.
Okay, thank you very much, reporter and opponent, for taking part in this discussion. And now we move
Thank you
on
very
to
much.
telephone questions from the reviewer, please.
Okay, hello, can you hear me?
Yes?
Okay, so first of all, a question for the reporter. How did you control the signal to noise ratio and how would you define it in your problem?
We defined it, as you saw on our slides, we defined the signal as the intensity per pixel, and our noise was defined as the standard deviation of the mean intensity of the background of the image.
To control it.
As you saw, the signal to noise ratio drops rapidly near the end of the galaxy. However, this is a nonetheless accurate measurement since we have much data from many isophotes closer to the galactic edge.
Thank you. Now, how can you define a statistical fluke and how did you make a difference between statistical flukes or weak problem?
Well, statistical flukes were unwanted in our measurements since the statistical flukes are generally because of the stars that are on the disk of the galaxy. And
I think statistical flukes are very important in this problem. They are certainly a key word.
we wanted to eliminate the influence from stars that are on the galactic disk. This is why we did the fitting with isophotes, so that only the galaxy would remain, and the other objects that are on the way to the galaxy will not, for example, if a star is closer to the center, it would enhance the brightness, which is not true. This galaxy may be this star is certainly closer than the galaxy.
Sorry. So you didn't observe any statistical flukes in your problem. That's what you're saying.
Excuse me, may you rephrase that?
You didn't observe any statistical flukes in your problem. That's what you're saying.
Well, statistical flukes are both
Okay.
these influences from other stars and some deviations in the background.
Okay. Thank you very much for the questions and the answers. And now we have preparation time for the reviewer.
Oh, okay. Can I start sharing my screen?
Sure.
Can you see it?
Reporter
Yes.
and the opponent control
Reporting
place.
team
I
can
see it
see
well.
the screen. Yes.
Yes.
Okay. So may I begin?
Yes, please.
Okay, so hello, my name is David Abrudan, and today I'm going to be a reviewer for Team Romania Limitless on the problem number 16, weak signals. This is the task of the problem, and I think some keywords are signal to noise ratio, statistical fluke, and very weak signals. The proposed problem had as well some keywords like close signal to noise ratio and space object. Now, I want to say that our team tends to believe that what our problem task suggests is that we should identify and realize how we can make a difference between meaningful signals and statistical flukes in a weak signal graphical appearance. Now, let's move on with the reporter's summary. He had some strong points, like the theoretical model was very well constructed on the astronomical background. He had a detailed experimental setup with the telescopes and all the softwares he used. He had a great link between the theoretical model and the experimental results, a great analysis of weak signals in the experimental part, and the reporter drew clear conclusions and drew clear hypotheses to resolve ties. And he also had some complete answers to the opponent's questions. Now, some weak points. He concerned too much on the information about the astronomy in the theoretical part. The theory about weak signals, statistical flukes, and signal to noise ratio is completely missing, and I think that is the most important part of this problem. Uh, and the different now the way of control of the signal to noise ratio in the experimental part, I don't think it was present. I think it wasn't presented, and I think it's very important. Now, for this, we give the reporter 2 points out of 5, as you can see in the right hand corner. Now, the opponent summary, some strong points. He observed that the keywords definition are missing, like we said before. He noticed the fact that statements ask for control data, not produced data. Observed that the task of the problem is not clearly achieved, and asked some relevant question about the environmental setup. Some weak points of the opponent. She didn't observe the fact that theoretical information about weak signal statistical flux and signal to noise ratio is completely missing. Asked too many questions about facts that we believe were sufficiently explained by the reporter, and didn't concern on the fact that the reporter had a huge theoretical gap. The task of the problem asked us to determine the difference between meaningful signal and statistical flux, no concern from the opponent. For that, we give him 3 points out of 5. Now, some clashes during the fight. The opponent asked about the accuracy of the telescope. The reporter explained parameters of the environment and of the telescopes. We think that's a clear answer for the reporter. The opponent, after that, asked how he could define a statistical fluke. The reporter answered pretty well. We agree with the answer, but suggest a general definition for statistical flukes would have been great in theory. Now, the opponent asked about how the reporter minimized the unwanted noise. The reporter answered pretty clearly, and we think it's a good question by the reporter and a question by the opponent and good answer by the reporter. And last, the opponent asked about the lack of large definition, if it is. And the reporter said no definition, and we think it's
Okay. We're out of time. I'm sorry. We need to stop here.
for your
Thank you
time.
very much for your review. Thank you very much indeed. And now we move on to concluding remarks by the opponent, please.
Hello. First of all, sorry. First of all, I'd just like to thank everyone for participating. I want to start by saying that the reporter and the reviewer did a really great speech. However, I just want to say that the reporter proved that the further away that the galaxy is, the weaker the signal gets, and that was their final conclusion. The relevance of their theory was just a little bit uncertain, and although the investigation was well conducted, it lacked a clear link to its theory and also to the original question statement. It was only very basically answered. Regarding the reviewer's presentation, I did actually observe that the reporter had missed out clear definitions and links to question statements. It was unfortunate that they didn't pick that up, but yeah, I did do that. So I'd just like to redefine that. Overall, it was a great presentation, and I'd like to thank everyone for participating. Thank you.
Okay, thank you very much indeed. Concluding remarks from the reporter, please.
Okay, so first of all, thank you for the discussion. It's really been a pleasure. I just wanted to address some things. In my report, I demonstrated how weak signals can be used in acquiring sufficiently accurate data for astronomical exploration. In this data, we distinguished the meaningful signal being the intensity of the pixels in the galaxy image from the statistical fluke being the background noise and the star and other noise caused by stars. Also, for this analysis, we used surface brightness, which has a generic characteristic that it does not depend on the distance to the object as per the definition presented, which makes it a great way for analyzing distance space objects. So thank you very much for the discussion.
Okay, thank you very much indeed. And now we move on to questions from the jury members. And in case jurors have many questions, please notify us about your questions in the text chat. So we start the clock.
May I ask the question?
Yes, please.
So the question to the reporter, the object is really far, so do you think that the interstellar extinction should affect your results, that the effect of the interstellar gases and dust there, and it affects the different spectrum differently? So have you made a research about that in any way?
Well, the interstellar extinction is a characteristic of the medium to the object. For our comparative study in the three spectra, the interstellar extinction would serve the same in all of the filters. Moreover, we used the fitting of the models to a galaxy that is not that far away in order to not have effect from the global expansion of the universe and from the redshift of the objects.
All right, thank you.
Okay, thank you. Further questions, please?
Excuse me, I have been disconnected for a moment, and I want to know if the reporter considered the magnetic fields in his experiment or not.
Well, we use in the experiment. I used the observational data of the galaxy obtained from the image on a CCD matrix, and this is from the visible light. This is from the light actually in the visible, in the blue, and in the red filter that is coming from the object to the observer.
Okay, Nikita, I think you have a question now.
Yeah, only in one sentence, reporter, please. What the result of your research? What did you reach?
Well, I reached what I aimed for to establish a photometric decomposition into all of the three filters. And this shows that the galaxy is more prominent in R, and the bulge is least prominent in B, since the stellar formation there is not so intensive, which coincides with the theory. And also,
Okay, thank you.
yes.
Okay, to the reporter, please. So the objects that you study in your work are galaxies, and you present us data about galaxies and their boundaries. And as far as I understand, in all these cases, you are sure from the beginning that the object that you see at this particular place is really the galaxy. So the question is, have you ever observed signals so weak that you were not sure whether it is a galaxy or a star or a reflection from I don't know, from a satellite? So did you observe the situations when your galaxy was producing so weak signal that you were not really able to distinguish it from something else?
Well, such observations, if made in non-ideal conditions, may result in a harder way to distinguish the galaxy. But since here with the photometry, we obtained lots of data for the brightness near the edge of the galaxy. This way, we can be certain of the accuracy of the results obtained because the data there was in sufficient amounts.
Okay, thank you. Further questions, please?
May I ask one? So to the opponent, You were dissatisfied that the reporter did not control the light pollution and the environmental properties. So, how do you think the reporter could have controlled the light pollution? What advice should you give?
Okay. So essentially, I wasn't dissatisfied with this answer. I did sort of see that they controlled it to an extent, and they also did end up using the different filters. So no, I wasn't dissatisfied with it. I was just clarifying that. Thank you.
All right.
Okay, any further questions, please? Any further questions from the jury members? Well, apparently we're out of questions, so let's thank the jury members for the questions and the team members for the answers. We'll now move on to the grading phase, and I invite all jurors to please decide on your grades. Okay, we're still waiting for the grades from one of the jurors. And those, when you are ready, please send us your grades. Okay, we're out of time, but obviously we need to wait for the grades from one of our jurors. Kunduz, please send us your grades for the stage 2. Kunduz, are you here?
Yes, yes.
Mm-hmm. Okay, good. So all jurors are ready now, and we can announce the grades, starting with the grades for the report. I will first read these grades, and then I will also copy them at a later point to the text chat, and then we'll have time to discuss the grades. So, to the reporter, Ilya, 18, Mikita, 25, Ina, 23, Kunduz, 17, Nicholas, 22, Raman, 13, Alexandra, 29, and Ahmad Riza, 20. To the opponent, Ilya, 16, Mikita, 12, Dina, 16, Kunduz, 15, Nicholas, 16, Raman, 17, Alexandra, 18, and Ahmad Riza, 16. To the reviewer, Ilya, 10, Mikita, 6, Dina, 7, Kunduz, 8, Nicholas, 7, Raman, 9, Alexandra, 9, and Ahmad Riza, 7. Thank you very much for your grades. And we will start with commenting. And I will start myself because apparently I understand very well the reason of some controversy in the grading and also in the arguments between the reporter and the opponent, and especially reviewer on the other hand. So basically the reporter has provided a very serious and very well done work with image analysis from an equipment which was of very high quality. The equipment was good, your analysis was really good, and the way how you analyzed your data and your results was fantastic. So you have demonstrated to be a very skilled young astronomer with very good skills to analyze data and interpret data and draw conclusions from the data. The controversy is coming from the fact that a very specific question in the problem statement, in the original problem statement, was about differences between something which is coming into your instrument and this something, this signal, is sufficiently weak, and you cannot really say if what you observe is galaxy in your particular case or something else. So you just collect, I don't know, 10 photons, and you cannot really say if this is a galaxy or not. And therefore, when, for example, the reviewer was asking you questions about that in particular, he was addressing this particular situation and this particular topic of finding the difference between something which you can easily identify as galaxy and something else which is not a galaxy, but your data is not of sufficient quality to make this difference. And in your experiments, as far as I understand, what you observed were always signals of very high quality. You always knew that these were indeed galaxies, not anything else but indeed galaxies. And the reviewers, and I think some of the jurors as well, were expecting you to pay more attention to the case of uncertainty, to the case where you cannot really distinguish between something which is not a meaningful signal and something which is. Okay, and now we
Excuse me,
can
may I shortly address one of these points?
No. Now we will have comments from the jury members, and then we'll have further discussion in the break. So, to the reporter, the lowest grade was 13 from Raman, and I would like to ask you to please comment on your 13. Yes. Okay. Okay, thank you very much. So you have clearly explained the reasons why you subtracted points and arrived to this low grade of 13, which is the lowest grade among our jurors. And this is why we also have many people in the jury, and the opinions of jury members may be different. In particular, I personally, I a little bit disagree with Raman's remark, because I think that here in the report, the measurements by the reporter were indeed very sufficient to detect these galaxies, because the reporter on purpose and consciously was selecting the galaxies of good image quality with a sufficient photon count, and therefore when he was analyzing his data was always of good image quality and of good statistical size, and therefore the reporter was always certain that what he observes is really the meaningful signal, and he can analyze this meaningful signal with good techniques. Okay, anyway, Alexandra, your grade for the report was the highest one. It was the grade of 29, almost the highest possible grade for any report in the IYNT. Could you please comment on your 29?
Let me speak on all three, my 29 for report and 18 for opponent. Okay, at first, all three of them did a great job develop and understanding the solution for me. At first, I did not understand for what there was the morphology diagram component of galaxy, but the first open-end question showed to me the defined is was needed. Choose, I disagree with the reviewer about too much info of from astronomy about, but this was one thing what I disagree with him. So the strong, powerful statement of problem and its solution as far as he could from report and a good necessary attachment from opponent and reviewer, for example, such as accuracy of telescope or differences between meaningful of signal wake bring to me fun experience. I did not put the highest grades for report just because I have some notes to him linearization graphs, and I thank you, comrades. It was amazing stage.
Okay, thank you very much. You have clearly explained the reasons why you arrived at this very high grade, almost the highest possible grade in the IYNT, the grade of 21. Okay, if we now look at the grades for the opposition, the single lowest grade was 12, coming from Mikita.
Okay, thank you for giving me opportunity to talk about this. I would like to comment on every person on this fight, and the first remarks come to the reporter. First, the first remark will be on the problem formulation. You didn't formulate the problem at all, so we don't understand what you solve. And if you limit yourself, I said it before, just say us that you limit yourself in this way and why do you limit yourself. And the next point is about your presentation. I guess your presentation skills were not sufficient for us just because we merely understand the result while we were understanding the methodology of your research, of your work. And the next point will be about results. You should declare your results in the end of the presentation so that every person in this room will understand what you want to do. And the next remarks go to both opponent and reviewer. And it is, if we see that problem in the task was not solved, we firstly ask why it is not solved. And if you see that it isn't solved at all, you have to either offer some ways of solving this problem or push the reporter to solve this problem on time, just on the go. And I saw that you were lacking experience in this field. It is obvious because the topic was so hard to understand. And as for me, you've done a great job, but you were lacking some expertise again. Thank you.
Okay, thank you very much. And at the opposite end of the spectrum, the single highest grade for the opposition was 18 from Alexandra. But Alexandra, you've already commented on your 18, I think, and I would like to ask someone giving a close grade to comment. But okay, probably Raman, would you like to say a few words about 17 for the opposition, please? Okay, thank you. If we now look at the grades for the review, we had the lowest grade of 6 coming from Nikita, but you've already commented on your 6. Some people were giving slightly lower grades, in particular Nicholas, would you like slightly higher grades than 6, I'm sorry. Nicholas, would you please comment on your 7, which is one of the lower grade for the for the review, I'm sorry. Would you please comment on your 7?
7 is fairly high score. It's the lowest, but it still was a very good review. I missed sharpness in some points, so I really liked that the reviewer addressed the lack of the understanding of the statement, of the initial statement, but I missed some sharpness of this investigation. So the review itself was good, but I will agree to Mikita that the reviewer lacked some experience in some perspectives. But it was good, pretty good, nevertheless.
Okay, good. And if we now look at the opposite end of the spectrum, my grade for the review was 10. It was the single highest grade. And basically, I had an impression that the reviewing team could, in principle, address all important features of this stage. And once again, to reiterate my personal opinion and my personal position, is that the work done by the reporter was excellent, and the analysis that the opponent was presenting was absolutely excellent. And at the end of the day, the signals that you were discussing and presenting were in fact strong signals because the data was of high quality. And when you face it questions, in particular from the reviewer, but also from the opponent, about weak signals and situations when you cannot really distinguish what you measure from a statistical fluke, from anything else which is not your measurable object, I did not feel that your answers were pretty much clear. And I think that the way how reviewer addressed and summarized the situation was very consistent, very clear, and therefore I gave the highest possible grade to the review. So once again, this was a very interesting stage, and as you see, even the lower grades from the jury members were very high because the performances of all teams were fantastic. And this is why this is the final fight of the IYNT. The performances of all teams are really nice. We're really behind the schedule now, so I would like to thank all teams for taking part in this stage 2. Let's make a break, perhaps a slightly shorter break, and please be back on time because we need to finish on time. Thank you so much, and let's be back for stage 3. Thank you.
Excuse me, I'm really sorry. May I address some of the questions?
Yes, please do it quickly. Yes.
Yes, I wanted to ask about the weak nature of the why the signal, why this is not a weak signal, since we have distinguished between the statistical fluke of the background and actually, indeed, the mean signal the mean signal to noise ratio for the entire galaxy is close to 7. That is obtained. So why is this not a weak signal?
It is a weak signal, and your experiments with a very good telescope and with very high quality image analysis software and methodology, they allow to process the signal very well. So basically all that you have done and presented was really good. The reason why some people were asking you questions and were unhappy was because you have devoted all your resources and time and attention to obtaining high quality data, right? And this was a really high quality data. And when you were asked about definitions that are important here and about situations when the data would not be of such a high quality as you obtained, I personally had an impression that you were not really like ready to discuss it, because once again your data was of high quality. So once again, this is a question of definitions and approaches, and once again your report was really good. I really enjoyed it, and as you see, all grades are very high, so I completely applaud your work. There is nothing to criticize in your work. The only point is that when you were faced questions about like comparing your work to the definition of the problems, I would expect a little bit more of like critical discussion, like weighting things and saying, yes, the signal is weak, but we use such and such and such methods, and we see the difference. Basically, if you would provide more discussion, in particular with the discussion with the opponent, I think that your report would be better. But once again, it was really good. And as you see in the grades, it was a fantastic report, and there is nothing to criticize in your report.
Okay, thank you for the explanation.
Thank you. Yeah, thank you.